Good afternoon all. I've got a couple of ammeters here. These are the ones I made from three parts. The INA219, well, ammeter chip on a little board, an Arduino Pro Mini, and this little OLED display. So that's now displaying milliamps. It's jumping around a bit. But I've noticed, and I'm sure people told me this at the time when I made this thing, that last digit isn't actually changing at all. So one change I'd like to make to this now is to remove that last digit. I'd also quite like to put milliamps on there, MA. This thing keeps tipping forward, so a bit of blue tack on that programmer board. This is the CP2102, I think it is. And that should hold that nice and still. Good. So yes, what I'll do is I'll get rid of that last digit, put milliamps on there, and then after that, I want to turn this into a wattmeter. Now that's relatively easy to do. We need to just add in a voltage measurement, and it measures it between one of these two pins. I can't quite remember which one it is. It doesn't matter too much because there's very little voltage across there, because there's only the voltage across that current sense measuring resistor, and that's 100 milliohms, I think. Between there and ground, so it measures the voltage between this point and ground, and then by multiplying voltage by current, of course, we'll get power in watts. Right, so here's the Arduino Sketch for the INA219. Up there you can see INA219 and the OLED. So it's got sort of U8G2 lib stuff that's related to the OLED, and it's also got INA219. We've got a couple of begins down here. Begin the INA219, begin the U8G2. That's for the OLED. And then in here, we've simply got one variable, current in milliamps, and then a few statements here which goes and gets the current. There's a get current statement there, and then prints it to the display. Now I've been reading the U8G2 documentation, and it seems that print is pretty much the standard Arduino print, and I saw from the article on that, well, maybe I'll go to the article on that actually. Right, so on arduino.cc, here's the information for print. Now it says it's serial print, but it kind of just works the same. Down here we've got print a number, and I can print a variable, and then comma, and then a digit, and that digit seems to be the number of decimal places. So if you put a 0 there, you get no decimal places. If you put a 2, you get 2 decimal places. That must be the default, because on my ammeter right now, I've got 2 decimal places, but the second one has no information in it. It's just 0 all the time. So I think I'm going to put a 1 in here and just have 1 decimal place. Right, so back in my sketch, I've got here U8G2 print current in milliamps. So what I'm going to do there is I'm going to go comma 1, and that should take me down to 1 decimal place. So let's compile and upload that and see what it looks like. And I've hit the camera start recording thing early. We should see some flashing lights on here once the compilation gets underway. I can't see. Oh yeah, there they go. That's flashing. And that's probably verifying. That should reboot. Ah, right, that's exactly what I want. I want the current to just 1 decimal place. This is milliamps, because there's no current flowing. So it's bobbing around the 0 mark. But yeah, that's better. That's got 1 decimal place. Right, now what I want to put on there is MA. I want milliamps on there, because I want to know when I plug these things in whether they're reading milliamps or watts. When I modify one for watts, I want to see a W on there so I don't get confused. So let's put MA in there. Right, so back to my Arduino Sketch. Now I'm printing the actual variable, which is current in milliamps, so that's a varying number. Now I want another line, and it's going to be again U8G2 print, open brackets. Now this is where I want a text string, so I'll open some quotes, milliamps, close the quotes, close the brackets, and put the semicolon in. That should do it. Compile and upload. Right, let's take a look when this thing starts flashing. I can't see my compile and upload because it's actually off the screen, but that should go pretty soon. There it goes. That's the reset light, I think. There's the upload. There's the verify. And it should come up with milliamps. Yay! That's pretty good. But as this jumps backwards and forwards between a positive value and a negative value, milliamps is kind of jumping all over the place. So I think what I'll do is I'll position milliamps on the right hand side of the display so that it's not jumping around. Let's try that. Right, for that, down here what I want to do is use this set cursor command both for printing current onto the display. So this one says start at the 0x position and start at position 32 in the Y direction. That means start on the bottom row of pixels. So let's just copy that, Control C, paste it in before this line, which is where I'm printing milliamps, and I want it right over on the right hand side. Now this is a 128 pixel display, so let's put it, what would half of that be? 64. We want a bit more than that. Let's try something like, I don't know, 85 maybe? 85. It still needs to be on row 32, so it starts printing from the very bottom line. So that should put the actual milliamps value, the constantly changing value, the left-hand side of the display, and then this bit, the string MA, will be right over on the right-hand side. So let's compile and upload. Right, that's uploading, and in a minute it will verify, which looks a bit different. That's because the TX and RX are sort of doing different things. Right, that's sort of what I wanted. Milliamps is no longer jumping about. My number jumps about because sometimes it goes negative, but unfortunately I've put that a little bit too far to the right, and I'm cutting off most of the A. So my guess is I want to come back about, I don't know, 8 to 10 pixels, something like that. Right, so here, when I set the cursor in advance of printing MA, 85 is too far to the right. So I want to go back a bit. I think I'll go, I don't know, 77, something like that. I mean, I'm guessing at the moment. I could work out how many pixels M and A take, but to be honest, if I'm making other changes to this code, I might as well just modify this each time I do it until I get it about right. So compile and upload. Uploading, verifying. Let's see if that fits on the display. Yes, that's fine. I can't see whether that's exactly on, but certainly don't think I'm clipping any of that MA now. Now the only trouble is if that went up to something quite high, like 800 milliamps, which does it print first? I think it prints this number first and then milliamps. So milliamps will always be sitting on top of the number, so the number might get hidden under the M. It's not a problem at the moment. What I ought to do, I suppose, is find a little circuit to connect onto here so that I've got some milliamps flowing and just see what the effect is. Right, so I've got this bulb. It's from a car. It's 12 volts, 5 watts. That's going to make it a bit less than half an amp, maybe 0.4 of an amp, so that's 400 milliamps. So I'm just going to connect that into there, screw that terminal down, and then I've got to find 12 volts somehow to connect up to that. Right, I've got a 2.1mm socket here, and I found some bits of wire. I'll probably use the black one because I'll be coming out of negative. So positive can go into V in plus. Oh, that won't fit in there because I haven't undone that little screw terminal. Right, that shoves in there. That's fine. And then negative, I'll link from the negative there round onto the bulb. I'll need a little connector for that. Right, this one I'll do. These are the little ones that Jeremy gave me, which are super handy. So that just pushes in there. And the other side pushes in onto the bulb. Now, I'm expecting about half an amp to flow around this circuit. That is a circuit, isn't it? I'm not going to blow anything up. No, okay, let's plug in my solar 12 volts, which comes from some lead acid batteries outside. There is a fuse on the other end of this cable. This actually goes to one of those cigar lighter plugs. There should be a fuse in the tip of that. It's probably 5 amps or something. We're only going to be drawing about half an amp, but I don't think we'll have any explosions. Let's find out. Okay, that looks good. And yes, pretty much as I thought. we've got now 352 point something milliamps, and the number is sitting under milliamps, and so we haven't got an ideal situation here. I suppose I could do an if statement if it's greater than a certain number. I don't know, chop that digit off. But actually what I might do is just make sure that digit goes in front of milliamps. So maybe I'll lay milliamps down as the first statement. We don't need that power supply. That powers this when it's not being powered from USB. Yeah, so I'll put milliamps down first and then write the number so I can at least see it. Right, so back to my Arduino Sketch. Here's all the stuff for set cursor, go and get the current value, print it. So let's chop that out, Control X. Now we do this set cursor and print MA. So I'll do that first and then paste this lot, Control V, paste the actual printing of the live numerical value after I've placed milliamps. So now the number should crash over the M, and even though it doesn't quite fit on the display, at least I get to see the number, which is the important bit. Compile and upload. Right, reset. That's the upload. That's the verify. What happens here? Yes, it looks like nanoamps, but it's not. It's just milliamps with half of the M removed. Now, if I'm going to upgrade this to a Wattmeter, I want to change that and put a W there. So that's what I'll do next. Right, so that's a very trivial change. That just means that instead of MA in there, I'm going to put a capital W for watts. Compile and upload. And the result of that should be a nice W there. Of course, I've set the X position for the M and the A, so I need the W pushed over further. Didn't think about that. I'll just do that now quickly. Right, so I've done that. That's quite a nice narrow W. That could probably go a little bit further up. I started it at pixel number 100, so maybe I'll increase that gradually as I add in the other code for watts. This isn't of watts, of course. This is still milliamps. There's no way that's 351 watts when this is only a 5-watt bulb. So now we need to calculate watts, and of course watts is volts times amps. Now, what's the variable that has volts in it? This one says get current underscore milliamp. So is it get voltage underscore V or something? I don't actually know. So what I'll do is I'll go to File, Examples. Now I'll come all the way down to now what's it going to be? It's Adafruit INA219. Not sure if that's on the screen. Get current. I think in this sketch it may also get the voltage. Okay, it's called, well, I suppose I can name it whatever I want, but they've named it float. Really what I want is the load voltage. Now they calculate the load voltage as the bus voltage minus the shunt voltage over 1000. I think what I'll do is I'll just get the bus voltage, which is the voltage actually at the power supply. It's not quite the load voltage because it'll be the load voltage will be a bit less because there's the burden voltage, which is across that current measuring resistor, that 100 milliohm resistor, but it's going to be pretty close. So let's have a float bus voltage equals 0, and then we'll do bus voltage is INA219 get bus voltage underscore V. I'll copy those lines and paste them into my sketch. Right, so my new lines are here. Float bus voltage equals 0, and bus voltage does a get, so INA219 is the object, get the bus voltage underscore V, so in volts. That will return it into this variable. Now to get power, we're going to need another float. So let's have float power, yeah, power will do, equals 0, semicolon. Right, so power we need to now calculate it. I can calculate it here. It will be power equals, and it will be bus voltage times current milliamps times 1000, won't it? Right, so that's that line there. Power equals bus voltage times current milliamps times 1000. Now, instead of printing the current, milliamps, I just want to print power. Power. Power in watts. Of course, I don't need to say it's in watts because they don't say that voltage is in volts. You know what I mean. Anyway, print the power. Let's compile and upload and see if that works. Well, let's see if it compiles first. Well, it compiled and uploaded, but I'm getting some really weird numbers here. I'm getting some enormous numbers. Why are they so big? Milliamps. Oh, maybe I need to... Oh, yes, if it's reporting it in milliamps, then I'm going to have like 1000 milliamps is an amp. This is about half an amp. Oh, I think I needed to divide by 1000. I think I got it wrong. Yes, here we are. You can stop shouting at the screen now. Yes, I got that wrong. It's divide by 1000. Fairly obvious when those really enormous numbers came up. Compile and upload. So, did I get that right? Let's find out. Upload. Verify. Should have a number round about 5 watts for this bulb. Oh, and it's not 5 watts. Why is that still wrong? Ah, yes, I know why. We actually don't have any voltage. I'm not reading the voltage. The point is, this module, the INA219, can only read voltage if... how does this work? I think ground on the Arduino, or ground on the INA219 current sense board, needs to be referenced, in other words, needs to be connected to ground on my high current circuit, which is actually this black wire here. So I need to run a wire from that connection there through to ground on the Arduino, I think. Right, I can't find a very easily accessible ground point on the Arduino other than the one that's on this power connector. Now this is a bodge because I will need that power connector later when I want to run this off 9 volts, but just to see whether this works, I can plug that in there, and then I can use this black wire because that's ground on the Arduino, and if I shove it in there, shouldn't go bang. It should give me 4.5 watts. Awesome! So I suppose the only thing really I can do now, just to sort of confirm that this is all working, I mean it obviously is, would be to put a little variable power supply in here. So what I might do is feed the 12 volts into a power supply. I might use a buck boost actually, and then raise the voltage above 12 volts to get more watts, and below 12 volts to get less. Right, here's a buck boost power supply. I can plug my 12 volts straight into there. Now, in case you're wondering which one this is, it's the Minghe Model D3806. I think that means it can put out up to 38 volts, which would probably kill that bulb, at 6 amps. Right, so let's transfer my 12 volt input, which is here, disconnect that, and plug it into the buck boost. Just see what it's set to. 18.5 volts is a bit high, so let's bring that down to 12. Right, about 12.2, that'll do. Current is set to 1 amp, that's fine, don't really need a current limit. And now I need to connect the output of that, and I have one of these conveniently little short 2.1 connect cables, which I think came with, these came with a, what was it, a power over Ethernet type system. Oh, that's not going to plug in there very easily. I'll rearrange this a bit. Right, let's try this. So we've got 12 volts there. Let's switch on and let's display volts. So at 12 volts, we've got 4 watts. Let's wind the voltage up to 12.5, 4.3 watts. 13.5, 4.8 watts. That's interesting. That's supposed to be a 5 watt bulb. Anyway, let's carry on going. About 14, 5.2 watts. And probably shouldn't go much above about 15 for this bulb. And there we've got 5.7 watts. So yeah, that's working fine. 5.7. Wind that down. Let's go really low. That's getting dim. 1.8 watts. I like my new Wattmeter. So all I need to do now is find a suitable ground point on this Arduino. There is one here, Actually, let me just get a bit closer on that one. Yeah, that one there next to reset, it actually says GDN, but I think it's ground. I think it's supposed to say GND. It's not GDN, garden. No, so I think that's probably a ground. So I could probably put a little pin in there, run a little wire over to my ground, my 0 volt point in my high current circuit, which is this circuit here with the bulb, and then this becomes a wattmeter. It just does require that additional wire though, so that it can measure the voltage at that point in the circuit and therefore indicate watts. Let's just wind that voltage back up again, get that thing back up to 5 watts, which is what it's supposed to be, and there it is. So that's pretty cool. My ammeter, which this one still is, actually it's a milliammeter, I suppose, because it is reading in milliamps. This one doesn't have the MA, has been modified to become a wattmeter, and I think that will be extremely useful in my Muppet experiments. Cheerio.